A very warm good afternoon to one and all present here. It's our pleasure that we have with us Professor Anurag Saxena, School of Management Studies, Indira Gandhi National Open University, New Delhi. He'll be delivering his precise expertise on quantitative data analysis. It's our pleasure to welcome you, sir. Now I request Dr. Moni, NAS College Meerut, to please present a brief profile of Professor Anurag Saxena ji.
Thank you, sir. Thank you very much. Good afternoon, everyone. We are back again with another session in this 7-day workshop. I, Dr. Moni Verma, Assistant Professor, Department of Chemistry, Biology Department, NAS College Meerut, welcomes you all on behalf of my college management committee, principal, staff member, and the person behind all these innovative ideas and bringing us together, none other than Dr. Sanjeev Mahajan, Head, Department of Sociology and convener of this 7-day workshop on research methodology jointly organized by Indira Gandhi National Open University Regional Center, Noida, and NAS College, Meerut. This is the 5th day of the workshop and we are heading towards our 16th session. Here I welcome Professor Anurag Saxena. This is my pride privilege that I have been bestowed with the opportunity to present brief profile of Dr. Anurag Saxena. Dr. Saxena is presently working as professor in School of Management at Indira Gandhi National Open University, Delhi. He formerly served as Deputy Director and held independent charge of the Center of Development of Evaluating Technology, CDET. He also worked as Director, School of Tourism, Hospitality Services and Sector Management, SOTHSSM. He even served in Planning Division at IGNOU. Dr. Saxena has a degree of Doctorate of Philosophy from Agra University. He is alumni of IIT. He did his master's in statistics from IIT Kanpur. Professor Saxena has more than 30 years of teaching experience in open and distance learning, ODL. He has more than 40 research papers in various journals of repute. He has authored 2 chapters in book and 21 units in and authored 1 book on supply chain management. For his international assignment, he traveled to USA, UK, Australia, Malaysia, West Indies, and Nigeria. He revised the course material of R1 research method for CE MBA program of Commonwealth of Learning for the School of Business and Administration, Wawasan Open University, Malaysia in July 2014. He did his statistical analysis for research on OER4D, a project of International Development Research Center, IDRC, Canada, undertaken by Commonwealth Educational Media Center for Asia in the year 2015. He has been awarded with Indian Bank sponsored gold medal for best researcher in the year 2004 by Indira Gandhi National Open University. His area of interest and his specialization include quantitative techniques, information system for managers, and supply chain management. He developed various courses for MBA program for IGNOU. Now, I request Dr. Anurag Saxena to deliver his valuable lecture on the topic to quantitative data analysis. Over to you, sir. Thank you, sir.
Thank you, Dr. Moni. Thanks for your kind words. I take this opportunity to thank our Honorable Vice Chancellor, Professor Nageshwar Rao, Honorable Vice Chancellor of Meerut University, Regional Director of Noida Regional Center, Dr. Amit Chaturvedi, and Dr. Sanjeev Mahajan for giving me the opportunity to present my talk on quantitative data analysis. I've been listening to other sessions in this webinar on one of these odd days. And I must congratulate the organizers to have such an enriching conference. Uh, the sessions were really good. So today, what I'm going to do is I'm going to touch upon quantitative data analysis. Till now, you might be having one or two sessions on quantitative data analysis, but I would like to break some myths today. I would like to break these myths in the sense that I want you to use the statistical techniques in a proper manner. So I'll start from scratch and I'll tell you the very basic concepts. From those very basic concepts, we'll try to move on to higher order concepts, and I'll tell you when to apply which kind of analysis. Is the setting all right? Are you able to see my slides and my picture?
The setting is all right, and we are able to see the presentation, sir.
All right. So I'll begin my presentation with a small narration. One day, one of my research students came to me. She said, "Sir, I've collected the data on ITC company from BSE, and I've collected this data from 2007 onwards on quarterly basis." I said, "Very good work you have done. So how do you intend to proceed?" She said, "Precisely, this is the reason that I've come to you. I wanted to know, in fact, I've identified some of the statistical techniques that can be applied to this data, and I want your approval on that." So I said, "What kind of statistical techniques you are going to use it?" She said, "I'll apply regression, I'll apply ANOVA. ANOVA is analysis of variance. I'll apply t-test, f-test, then I'll apply cross tabulations, and sir, I'll also try to apply structural equation modeling." I said, "Very, very nice. You have identified these techniques in a very good manner. Now let us see your data." If you have seen the data on Bombay Stock Exchange, it is basically the time and the value of the share. The share chosen was ITC. So only two columns of data is there. One is the time, the quarter from where you have drawn the data. Other is the stock price. Now, many of you would wonder whether all these techniques that she has narrated or she has identified are applicable on this particular type of data. This is a particular example of a time series data, and then you cannot apply anything else but for regression on this data. Now, this is the problem faced by many of the researchers. They collect data, and what is the method of collecting data? Most of them use survey method. They prepare a questionnaire, get it filled, and this is how they proceed or generate data for their study. I'm not talking of business research or physical research, physical sciences, where you have got precise data from experiments. Say in business, you could have generated data from the stock exchange, or you could have generated data from the company itself, and so on. I'm in particular talking about social science research, and most of us are abundantly dependent on the survey analysis. So what kind of data you are getting in the survey and what kind of analysis you will apply, this will be the crux of my talk today. And to enable that, I'll go on to my first slide, and I'll tell you about what kind of characteristics are there when you are actually measuring the data. Now, I define four kind of rules. They are called mapping rules when you basically measure something. One is classification. I'll give you an example of this. Suppose you are sitting at a mall and you are observing the people entering the mall. So either it could be a male or it could be a female. So basically you are classifying the entrants by gender. So here in classification, only numbers are used to group responses. You'll say that I assign number 1 to male, number 2 to female, but there is no order here. So this is called classification. But if you order them, suppose I take the example of a beauty contest where judges are giving ranks to the participants. Then there is some order there. So second mapping rule is order. Third one is the distance. Now, even if you order, you assign ranks to the participants, there is no distance. You cannot say that one is 4 points distance from 5. There is no order. When we talk of order, we talk of grade point averages. In Indira Gandhi National Open University, we assign grades in many courses, many programs. So there you can say that yes, A and C are different. A corresponds to 5 point average and C corresponds to 3 point average. So basically here you are talking of differences between numbers and you are talking about order also. And fourth one is called origin, where 0 is defined. When I took the example of grades that Indira Gandhi National Open University assigns for various programs, there is no 0. Even if you get an E grade, that carries 1 point. So there is no 0. There is no absolute 0 here. So I'm going to make an accusation now. This accusation is that most of our books on statistics are written for those variables which are having all these mapping rules: classification, order, distance, and origin. So what to do when some of these rules are missing? I'll talk about these things. I'll try to define the 4 types of variables. And I'll also tell you when you will encounter these kind of variables. So let us define these variables now. I'll name all of them now. One is nominal, other is ordinal, third one is interval, and fourth one is ratio. I'll go back to my previous slide and have you to have a relook on the mapping rules. Classification, order, distance, and origin. Now, let us, on the basis of these mapping rules, let us define the variables. Nominal variable, where classification is there, but no order, distance, or origin is there. Ordinal variable, classification and order is there, but no distance and origin. You're seeing that I'm taking it one by one. Nominal has classification only. Ordinal has classification and order, but no distance and origin. Interval has got classification, order, and distance. So we are now addressing to 3 mapping rules, but no origin. And ratio variables, they have got all the 4. That means classification, order, distance, and natural origin. We call them higher order variables. Say nominal is the least order variable and ratio is the highest variable. So what I was trying to tell you is most of our statistics books are referring to interval and ratio variables. They do not take care of nominal and ordinal variables. And even if they take care, they are not dealt in a proper manner. You must have seen previous researchers when people used to report their data in the form of mean plus minus 2 SD. Now, what is this mean plus minus 2 SD limits? In 80s, in 90s, most of the researchers are reporting mean plus minus 2 SD, minimum, maximum, at the most, coefficient of skewness and kurtosis. Actually, to report the variables in this manner is only applicable for the interval and ratio variables. This is not applicable for the ordinal and nominal variables. Now, I've given you example of people entering the gate of mall, and you are recording them. You are recording whether male is coming or female is coming. So male, female is your data, and you have collected observation on, suppose, 100 people. Now, if I ask you to report your data in the form of statistics, what will you do? Can you describe them on the basis of mean and standard deviation? Is that a number? We cannot do that. So, for nominal variable, it is not applicable. Similarly, we cannot find the mean of ranks. What does it mean? If I've got numbers from 1, 2, 3, 4, 5, 6, and I take mean, the mean will come 3. So, if I'm dealing with ordinal variable, this doesn't have any meaning. So, the mean plus minus 2 SD, and why mean plus minus 2 SD is said? Because we say that it is 95% confidence limits. We have got 95% confidence. You must have heard about the terms called level of significance and so on. So, 2 mean plus minus 2 SD is coming because 95% corresponds to 1.96 of standard normal weightage. You might not be getting many of the terms that I'm talking now, but slowly when this lecture progresses, we will make you understand these things. And we'll also talk about methods for the ordinal and nominal variables, which actually is going to benefit you because if you're a social science researcher, you will be using questionnaires, and how to analyze these questionnaires will be dealt with in the subsequent slides. I'll narrate a very small cliplet or very small story. The unexpected is so beautiful, it creates surprises. And statistics is bound to be a subject that is bound to create surprises because you are trying to derive hidden patterns from the data. You are trying to derive hidden patterns from the data by the use of statistical analysis. What is unexpected, you can see in this slide that a doctor is telling the patient that your check has bounced. And the patient is replying that my fever has also come back. So, this should be the way that doctor has treated and the treatment has failed. So, he should not be taking this fees. Statistics will allow you to generate these kind of surprises. So, let me define the nominal scale in a proper manner with the help of examples. Nominal scale is basic comparison to compare the identity of person. Suppose on off, there is a switch, you can on it, you can off it. Male, female, user, non-user, occupations, uniform number. So, if I give you an example, your question in the questionnaire would be like, Which of the following soft drinks do you like? Check all that apply. So they've given options like Coca-Cola, Mountain Dew, 7-Up, Fanta, Pepsi, and Sprite. And you can pick whatever soft drinks are liked by you. Now, again, I go back to the example where I've said that you're observing the data of people entering the gate of a mall. If I ask you to give a statistical analysis of that data, you would say that, say, 75% of people entering the gate were male. And how you have reached to that analysis? That means you have selected the most number of people entering the gate and you have identified their gender. Not many people would know, but you would say that I've said on an average 75% entering the gate are male. That means I'm using the mean. In fact, you're not using the mean, you're using the mode. Mode is the most frequently occurring value of a distribution. So 75% means this is the most frequently occurring value and this is the mode. So for nominal scale, our measure of central tendency is mode, not the mean as reported in various researches. It is not the mean, it is the mode. And there is no measure of dispersion because you cannot calculate on the basis of male-female only. You have got to get numbers in order to find the measure of dispersion. Secondly, we move on to the ordinal scale. Here the order is compared. So examples are branch preference, social class. Social class means Hindu, Muslim, Sikh, Isai. Hardness of material, quality of lumber. Now here you can revise your questionnaire. The question that will go into the questionnaire, you will say that you rank the following soft drinks from 1, that is least liked, to 6, that is the most liked. Again, what you are going to do here is, there are 6 brands of cold drinks given. You will give ranks to them according to your choice. Suppose you like Pepsi, you will give 6 to Pepsi. And you least like Mountain Dew, you will give 1 to Mountain Dew. So in this way, you are assigning the rank. Here, measures of central tendency are median and mode. You can use both of them. Median is the value that divides the series into 2 equal parts. So, you can say that at the middle sitting is Fanta because it has got the rank 3. That much you can say. You can say that many people like it, many people don't like it. So it is sitting in the middle. But certainly, more people are not liking Mountain Dew because it has been given the least rank. Let us move on to the third one, that is the interval variable. Interval scale, you compare the distance also. So order, classification, and distance. And the most popular case of interval scale is the thermometer, where you have got values from say 94 to 108, and you measure temperature, but there is no absolute zero. The other example that I've already given is the grade point average. Another example could be brand attitude. Now, how would you redesign your questionnaire here? You see the question at the bottom of the slide. What is your overall opinion about each of these brands? You mark them from unfavorable to favorable, and this is a 7-point scale. Now, this is a typical kind of Likert scale that most of you use in your surveys. So, it is an interval scale variable. And again, here you can use mean, median, and mode. You can use mean also, although mean doesn't have much value here. Again, if you take the mean from 1 to 7, it will come to be 4. So you cannot say with certainty, but you will have some kind of judgmental decision making that 4, that means it is coming in the middle. Next one is the ratio scale. Now, this is the data that we use in business research and physical sciences. Here we compare the absolute magnitudes of the value, say units sold, number of purchases, age, income. Age and income can come in nominal and ordinal variable also, but age, when you ask age in numbers, it will come in the ratio scale. Suppose you give ranges, say 1 to 20, 20 to 40, 40 to 60, 60 onwards. Then it will become an ordinal variable. But if you are asking the age in exact numbers, it will become a ratio variable. Similarly, income, if you are giving income bands, it will become an ordinal variable. If you are asking the income in absolute figures, it will become a ratio variable. So you change your questionnaire like this. You divide 100 points among these soft drinks according to your likelihood of purchasing each within the next week. So you have to assign numbers from, you have to actually divide 100. Suppose you give 20 to Coca-Cola, 20 to Mountain Dew, 20 to 7-Up, you've got 40 points to divide between Fanta, Pepsi, and Sprite. So this is the example of a ratio scale. Now I'll tell you what kind of statistical techniques are applied when we are dealing with these nominal, ordinal, interval, and ratio kind of variables. I've given two rules on the slide. One is rule A and other is rule B. So rule A, if you see closely, it is basically overlapping classes, because a Christian can be Catholic, it can be Protestant also. So this rule is not valid. We can see rule B is valid because they are having non-overlapping classes. So the analysis that we can use here is called cross-tabulation. By cross-tabulating nominal variables with others, it gives pattern in the data. And it is very useful in the exploratory work. And basically what is research? It is exploration. What you try to formulate something and you try to collect data on that, and you do a statistical analysis to explore whether those data have got any significance. And this is what statistics do for you. Nominal scales are widely used in surveys and research where data are classified in subgroups. Suppose I'm talking of an election and I divide the country in zones. Suppose northwest, east, south. And I want to see the performance of various political parties, suppose BJP, Congress, and others. So in my rows, I've got 4 zones. In my columns, I've got 3 parties. It is a 4x3 matrix. And this is what I mean by when data are classified in subgroups. So cross-tabulation provides insight into various demographic variables, and most popular statistical test is called chi-square test. So I've started giving you tests for your analysis, and the first and foremost and very important is chi-square test. It is valid for nominal and ordinal data. If you've got ratio and interval variables, then chi-square test is not applicable. And I'll give you example why it is not applicable. I'll show you a live, not live, but a screenshot from the SPSS where I'll prove that chi-square test is applicable only for nominal and ordinal data. Examples of ordinal data include attitude and preference scales. They are basically based on the rankings. You must have solved many numerical problems where two judges are ranking participants, and both of these judges have given different kind of rank, and you are asked to find the association between them. We'll discuss how to find the association between these ranks, but here the measure of central tendency is median, and measure of dispersion are quartiles and percentiles. And what are these quartiles and percentiles? Quartiles are those numbers which divide the series into 4 equal parts, and percentiles are those numbers which divide the series into 100 equal parts. So I'll make a statement and you'll try to understand what I'm going to say. Median is equal to second quartile, 5th decile, and 50th percentile. You must be aware that percentiles are used in big way in our education scenario. In fact, if you see that the CAT examination for the management entrance use percentiles. And statistical tests are confined to non-parametric tests here. Chi-square is also a non-parametric test, but apart from chi-square, we apply many other non-parametric tests. Now, just a word about non-parametric tests. Why are they called non-parametric tests? Because they don't involve any parameter. So this is the English definition of this. But what are they? Exactly what are non-parametric tests? Again, I'll go back and curse the books available on statistics. Most of them pertains to the parametric test. They talk about bivariate normal distribution. They talk about numbers. They talk about T, F, Z, chi-square, and so many tests. But they are parametric. So, what do you understand by parametric? Actually, the whole statistics is based on the assumption that if we are taking large numbers of data, all the data comes from the normal distribution. You must have heard the word normal distribution. If you have not come across the word normal distribution, I'll explain it in a simple manner. Have you ever seen a truck containing sand unloading? When that unloads, you find a bunch of sand accumulates in the form of an umbrella. That umbrella figure is called the normal distribution. We are talking about thousands of particles of sand, and when truck unloads, it comes to be a normal distribution. So anything in the form of an umbrella is normal distribution. But the problem with ourselves, when we do research, when we do surveys, we seldom find normal distribution. Once normality assumption is not followed, we cannot go for parametric tests. Once we cannot go for parametric tests, we have to use non-parametric tests. And I'll show you figures in the next slide, what is meant by a normal distribution, what is a skewed distribution, and so on. So for the time being, you can console yourself with this fact that for ordinal scales, we use non-parametric tests. you see the figure on the screen, the middle one is a normal distribution, and it is a symmetric normal distribution. Normal distribution is always symmetric, in fact. The one with a peak on left and tail, a longer tail on the right is called right skewed. Similarly, the rightmost figure is the left skewed figure because the tail on the left is very long. So it is left skewed. Now I'm giving you a rule, you can note it down, that interval scale incorporates concept of equality of intervals. Now the rule that I want to understand and note down is that when the data is symmetric, that means the middle figure, then only we can use mean and variance. I'll repeat, when the data is symmetric, then only we can use arithmetic mean and variance. When the data is skewed, that means the figure on the left side and figure on the right side, we cannot use mean and variance because we are flouting the normality assumption. And the whole statistics is based on the assumption that our data comes from the normal distribution. Whereas in your research, when you've collected data, it is not coming to be normal distribution. So when the data is skewed or it is not normal, we use median and interquartile range. A very good example I've given here is that elapsed time between 2 p.m. and 4 p.m. is 2 hours. So can you say that 4 p.m. is twice as late as 2 p.m.? We cannot say that. We cannot say that. So we can at most say that 2 hours have elapsed between 2 p.m. and 4 p.m. So 120 minutes or 2 hours have elapsed. But the good thing is that with interval scale variables, you can use statistical procedures of choice such as correlation, t-test, and f-test, and other parametric tests. But again, the caution is that you have to check for the skewness of your data. The other vignette is called kurtosis, that is the peakedness of the curve, but that is not more important. More important is you should draw a frequency distribution and you should check whether your data is skewed or not. If it is skewed, don't use mean and variance, use median and interquartile range. Now coming to the ratio scale, and that is the best scale, the higher order scale. Here we have got absolute zero. So in some programs, Indira Gandhi University doesn't use grades. It gives the absolute marks. So zero is possible there. So when zero is there, we say that the origin exists. So in business research, we find ratio scales, for example, money, return rates, productivity rates, and times. We use geometric mean, harmonic mean, coefficient of variation, and other methods here. It can be converted, rescaled, or reduced to a lower level. And all the statistical techniques that you find in books are usable here. So if you are doing research and your data is a ratio scale, I've already defined ratio scale. So if your data is ratio scale, then you can use the statistical techniques that are mentioned in the books. If it is nominal and ordinal, beware of using it. You try to find an appropriate method. Some of those methods I will discuss today. So this table is a very important table. If you see this table very clearly, on columns, I have taken nominal, ordinal, interval, and ratio. On the rows, I have taken nominal, ordinal, and interval ratio. I'll be using some terms that you might not have heard about, such as Kramer's V. So if you are dealing with, I'm giving you a way to read this table. See the first row and first column. You will go for nominal and nominal variables. So if you are going for nominal and nominal variables, you can use contingency table, chi-square test, and Cramer's V. Similarly, for nominal and ordinal, you see row number 1 and column number 2 will encounter nominal versus ordinal variable. So contingency table, chi-square V, and Cramer's V. Again, a typical example of this would be zones and political parties, 4x3 table. If you're going for a 4x3 table, you can analyze the independence of attributes of that particular table with the help of chi-square and Cramer's V. I'll give you the formula of Cramer's V, how it is calculated. Similarly, you see row number 1 and column number 3, which pertains to nominal versus interval and ratio data. Here, you can basically use contingency tables, chi-square, Cramer's V, and the question is, if the interval ratio variable can be identified as a dependent variable, you can use ANOVA, that means you can use compared means, and eta. Come down to row number 2 and column number 1. This is ordinal versus nominal. We have already discussed that. What happens when we deal with ordinal versus ordinal? There we use Spearman's rho, which is also called the rank correlation. You must have done questions on finding rank correlation. So now I am redefining it. I am saying this is the ordinal versus ordinal. Go to column number 3, interval and ratio, and row number 2, that is ordinal. Again, we use Spearman's rho, that is the rank correlation. And the last one is when you go for row number 3 and column number 3, that is interval and ratio scales. There you find Pearson's R, Pearson's correlation coefficient. So the slide number 14 of my presentation is the Bible. You can take a screenshot of this, and on the basis of this, first you will identify your data and then apply the appropriate technique. We talk a lot about correlation coefficient, and we use it in a very heavy manner, but there is something more called coefficient of determination on the basis of correlation coefficient. Let me define coefficient of determination for you. But before that, you see this figure, and you see the value given on the top of figure is the correlation coefficient. Correlation coefficient is 1 in first case, where there is a straight line, and as the line gets scattered, you can see that the value of correlation coefficient gets decreasing. That means you see the first row, from 1 it has come down to 0.8 to 0.4 and finally to 0, because the figure pertaining to 0 is all scattered. It doesn't make sense when your data is making patterns. Unless it is a straight line, the value of the correlation coefficient will be low. You can see that there is a perfectly negative correlation when the line is going downwards. And the slope of the line doesn't matter. If it is a horizontal line, correlation coefficient is 0. So And in the bottom row, all the correlation coefficients are 0. They are making nice patterns, but they are not concentrated about a line. So all the correlation coefficients are 0. That means there is no correlation between these data points. Although they are making patterns, but there is no correlation. This is what I was telling you about the coefficient of determination. If you found your correlation coefficient, Pearson's correlation coefficient, that is R, and you double that, you will get, double in the sense, you square that, then you get coefficient of determination. And what is the significance of coefficient of determination? It tells you about how much of variation in one variable is due to other variables. Suppose your correlation coefficient is minus 0.27. When you square it, you'll get 0.0729. We take up to 2 decimal points, 0.07 is your R square. That means your data, variation in your data is explained only by 7%. That means the statistical technique that you are using is explaining your variation only by 7%, which is a very poor result. So, R square, that means coefficient of determination, is a tool which tell you when variables are of different types, how much of the variation is explained by the statistical technique that you're using. Suppose your variable are not interval ratio, then you cannot use R. I'll again give you a small story. It says that understanding gives you power of clarity, misunderstanding creates silliness. And look at the absurdity in the story. There was a monk and he has got a student. And he asked a question, if you find 50 lakh rupees, what will you do? The student was very intelligent and it analyzed the situation very quickly. It says, sir, it all depends. And what all it depends? It depends on if it belongs to a poor person, I'll return it. If it belongs to a rich person, I'll donate it to a monastery. Now see the absurdity in the statement. If it is a poor person, he cannot be having 50 lakh rupees. True? And if it is a rich person and he has lost that 50 lakh rupees, the monastery won't require money. The monastery doesn't require 50 lakh rupees. So there is an absurdity. Although the analysis of the student is perfect, he has analyzed both the situations. So finally, after defining our variables, nominal, ordinal, interval, ratio, we are coming to a very important technique in survey research, which is basically exploratory in nature. So cross tabulation is a basic technique for examining the relationship between two categorical variables. What are these categorical variables? I'll say that nominal and ordinal variables are put under the tag categorical variables. For example, age and income. So it is the first step for identifying relation between variables. When the tables are constructed for statistical testing, they are called contingency tables that I've given you in the slide number 14. So contingency tables, you test the independence of, suppose I've taken that example of voting, zones versus political party. So I set up a hypothesis whether the zones have any dependence on the winning of a political party. So that we will test through a contingency table, and we will apply chi-square test. And chi-square test determines if the classification variables are independent of each other or not. So whether the zones are dependent on political parties or political parties are dependent on zones, that we can apply a chi-square test and we can have a claim that there is no dependence of political parties on zones, or there is dependence, and so on. Now this figure I have taken from SPSS, and this is one from one of my research papers where I've classified it according to nature of the institution. That means the face-to-face teaching institution, distance education or dual mode teaching institution, and male-female. So this is a typical cross tabulation, and I've given it the name nature of institution versus gender cross tabulation. It is a 3x2 table because you have got 3 rows and 2 tables. The blue shaded portion is called a cell. That means it gives the count of male in the distance education institute, that is 23. This is called a cell. And how I am going to describe this cell is by saying that count of students who are male in distance education is 23. This is by description of the cell. This is called cell description. And you see the last row here, this is called the marginals because it is totaling the count, the column total. So 43.1% is the marginal. This is how I define a cross tabulation. And I can go further in a cross tabulation. Here I'm using a layer. It is language, gender, and technology use. So I've added a third dimension here. I'm using a layer. It asks you whether you use the technology or not. Then it asks you about gender, male and female, and you use technology in which language. This is the third dimension. That means English, Hindi, or Urdu, English, or Urdu, English, Hindi. So it is a table which is adding a dimension. So this is called a three-way cross tabulation. You can see this is a very informative table because it is giving you exactly those who do not use technology or they use technology. See the second row, they use technology, and there is one person who used technology in Urdu also, and that person is a male. So from this table, we can comment on many of the things that data cannot comment upon. So this is a very good way of providing, and then you can apply a chi-square test on this table also. So chi-square test is the most widely used non-parametric test. It is useful test involving nominal data, but can be used for higher scales also. Typical cases are when persons, events, or objects are grouped in 2 or more nominal categories or classes. I've given you examples: A, B, C, D, favor, undecided, against, yes, no. Although I've said that it can be used for higher scales, but although you can use it, but if you are dealing with interval and ratio scale, you avoid chi-square test because there you cannot confine to number of rows and columns. Suppose you are using ratio scales and the values are 1 from 50 and you are looking onto 3 political parties. So it will be a 50 by 3 table. Now you can apply chi-square, but it will be very difficult to interpret. So that is why we say that it is confined to nominal and ordinal data, where we have limited number of categories and we can understand or interpret that table. You cannot interpret a table 50 by 3. It is as good as raw data. So ordinal, suppose we have got 5 categories, versus ordinal, suppose you have got 3 categories, it will be a 5 by 3 table. Although difficult to interpret, but yes, it can be interpreted. Now I define a concept called degree of freedom for a chi-square test. It is in 2 samples and k samples. Degree of freedom is defined as row minus 1 into column minus 1. So suppose you have got 5 by 3 table. 5 minus 1 is 4 and 3 minus 1 is 2. 4 into 2, 8. That will be the degree of freedom of chi-square. And I'll show you a figure where degrees of freedom is coming into picture. It basically defines the shape of the chi-square curve. So if degree of freedom is 1, each expected frequency should be at least 5. And if degree of freedom is greater than 1, 20% of the expected frequency should not be less than 5. This is the basic rule. And we used to do questions on chi-square where we used to club the classes. Suppose expected frequency is not coming up to 5, then we used to club the classes so that the expected frequency should become 5. Now, why I define degree of freedom, that can be explained by this figure. Here k is equal to 1. Now it is coming to the shape of a hyperbola. And when you go for degrees of freedom, k is equal to 9, you'll see that it is taking the shape of a normal curve. So if H0 is true, then sampling distribution of chi-square is a chi-square distribution. And you keep on increasing the degrees of freedom, it resembles normal distribution. So in the figure, if the degrees of freedom is 9, then also it is coming to be a quite similar curve to normal distribution, although it is right skewed. I define chi-square as summation OI minus EI divided by EI, and numerator OI minus EI square. What OI means? It is the observed frequency, and EI is the expected frequency. So what we do is we try to find the difference between the observed and expected frequency, square it, divided by the expected frequency, and take sum of all these values. So this becomes a chi-square variate. Now I'm showing you a screenshot of SPSS. Don't worry about the formulas and other things that I'm giving you because you are not going to use them. They are basically meant to make you understand as to what SPSS is doing with your data. This is again from one of my research where I have taken variables like age, designation, discipline, highest qualification, teaching experience, nature of job, language, institution, nature of institution, number of students, previous open educational resource use, and mean of the attitudes. It was an attitudes of OER used by the students. So in the rows, I've taken gender, and in the column, I've taken median of attitudes. Now see to the right of the screenshot that you're seeing on your screens, I've ticked up chi-square, but I've not ticked anything. And these columns under nominal, you can see contingency coefficient, phi, grammar v, lambda, uncertainty coefficient, and in ordinal, you see gamma, Thomas D, Candlestow C, kappa, risk, McNamara. Now, I don't want that you should cram the formulas of all these which are given here, but you try to understand that when they are applicable. So, here, gender is a nominal variable, median attitude is an ordinal variable. I can go for gamma, Thomas D, Candlestow B, Candlestow C. And let me define what these are actually. You must have not heard about the formulas of all these, but I'm trying to give you a glimpse of the formulas of all these so that you understand actually what they are. And don't worry to implement the formula. Formula will be implemented by SPSS. The only thing is you need to appreciate what SPSS is doing. The subsequent slides are going to be a little mathematical, but again, I said you don't need to remember the formula. You need to appreciate that this is what is being done inside SPSS when you subject your data to find phi. Phi is best suited for 2 by 2 tables. It is a measure of efficiency for nominal non-parametric variables. And what we are doing nothing here. What we are doing is we are dividing chi-square by the total number of observations and taking the square root. So phi should not be a difficult thing for you. It is chi-square only, your age-old friend chi-square. You all know about chi-square. So here what we are doing is we are taking average of all chi-square values and we are taking under root and we are defining it by phi. Similarly, Cramer's phi is also a measure. You see, very little deviation has been done. If you compare phi with Cramer's v, what they have added here is they have added a term called k minus 1, where k is the lesser number of rows and columns. So this is more suitable for tables which are larger than 2 by 2. So only a term k minus 1 is added here, which is lesser number of rows and columns, and this is called Cramer's v. I define two concepts which is for measures of ordinal data. Very important for you because you are often using Likert scale in your questionnaire. So I'm defining two concepts which is called concordant pairs and discordant pairs. When a participant that ranks higher on one ordinal variable also ranks higher on another variable, then we call it a concordant pair and we add 1 to value of p. Similarly, discordant pair, when a subject ranks higher on one ordinal variable but ranks lower on another variable. Before I go for use of these concordant pairs and discordant pairs, that you can easily find from your data as to where there is an agreement on ranks or where there is a disagreement on the rank. One word of advice here is that gamma, tau, d, and rho does not require assumption of a bivariate normal distribution. Now this is very important because I said that all our statistical books are dependent on the assumption that we are having a normal distribution. If we are not having a normal distribution, then we should use techniques which does not require the assumption of a bivariate normal distribution, and that is gamma, tau, d, and rho. Now you have calculated P and Q. I'll go back to P and Q again. Concordant pairs and discordant pairs. You have calculated the value of them. So once you are having P and Q, you can define Goodman and Kruskal's gamma, which is simple as P minus Q divided by P plus Q. So if you are having a smaller data, you can practice this. You can find concordant pairs and discordant pairs, and you can use the formula gamma is equal to P minus Q divided by P plus Q. So this is Goodman and Kruskal's gamma. And similarly, you define Candle's tau B. Why this is needed? Because sometimes you find a tie exists between the ranks. If there are tied pairs, then we use tied pairs also. We define them by Tx and Ty. That means the x variable, if ties are there, in the denominator, we subtract that. So the formula becomes P minus Q divided by under root n minus 1 divided by 2 minus Tx. This is for the x variable, and similarly for the y variable. So we call it Candle's tau B. Again, there was a refinement made, and it is called Candle's tau C. So Candle's tau C is a refinement of gamma for ordinal data that considers tied pairs, not only discordant or concordant pairs, for any size of table. Candle's tau C is basically for bigger size of tables, say 5 by 3, 6 by 3, 5 by 4, and so on. So 4 is the smaller number of rows and columns. So in the denominator, we divide it by 4 minus 1. That means m minus 1. And in the numerator, we put m. The formula becomes 2m p minus q divided by n square m minus 1. Now the formula might be looking difficult, but there is nothing difficult here. M, suppose you are using a 5 by 4 table, m is 4. Suppose there are 6 concordant pairs and 4 discordant pairs, so 6 minus 4 is 2. You have 10 pairs, so 10 square, and 4 minus 1. So it's not very difficult. It is basically understanding what Candle's tau C means. And Somers D is a measure of accession of ordinal data that compensates for tight ranks and adjusts for direction of independent variables. So I'll read the formula. D symmetric, Somers D symmetric is P minus Q divided by n minus 1 minus Tx Ty divided by 2. And you define two Somers D. One is from y to x, one from x to y. The formula are given on the ties that exist between the variable x and variable y. So this is Somers D for you. Now this is something that you must have read in your research methodology courses or quantitative techniques courses in your MBA or MA or MSc, whatever you have done. Spearman's rho. It is basically called the rank correlation. So it correlates ranks between two ordered variables. Researchers often find continuous variables with too many abnormalities. And the benefit of this is that even if you transform the data, it will not affect the rho. The formula goes like this: 1 minus 6 sigma d square divided by n square minus 1 into n, or n cube minus n. If you take n common here, you'll get n square minus 1. And you can calculate student t, which is given as rs under root n minus 2, 1 minus r square. So basically, I'm coming towards the end of my presentation, and I would ask every researcher to ask himself or herself that what do I plan to do within the data, with the data. You've collected the data, and what do you plan to do with the data? This is the first question that you should answer before collecting the data and after collecting the data, both. You should collect that kind of data which is basically solving the objectives, the research objectives of your research proposal. So if you want to describe only, you use descriptive statistical summary. If you want to explore, you do cross tabulation. If you want to discover the difference, that you go for hypothesis testing, but again, this is for interval and ratio variables. If you want to find relationships, then you can go for measures of association. That means the regression and correlation. So many people used to use statistical techniques in the research. It is definitely a good practice to substantiate your claims with the help of data. But the problem is that seldom you are using appropriate statistical techniques so that you reap the real benefits from your data. There are basically 6 categories of data, of statistical techniques. 4 I've mentioned here. Then you can go for multivariate techniques and non-parametric techniques. Well, this was all from my side. I would like to end with a small story, and here it goes. It's called the case of a dancing cow. There were 2 musicians, and they started arguing as to which of them wrote a better music. So Keshav said that my music is better. My melodies can bring tears to the eyes of women. And Mahesh said that my music is better. My music are more enchanting than anything. Your music cannot move a cow also. So they decided that they will make music for the cow. So they asked a peasant that, would you mind if we play something for your cow? The peasant agreed. So Mahesh played best of the most beautiful melody ever heard by the cow, but the cow was unmoved. And this similar thing happened with the Keshav, who played a lively score with the same result and no reaction from the cow. They both said that it is a lost cause and the cow doesn't have a musical ear. Then the peasant said, well, if you don't mind, I would like to play something for the cow. So what peasant did is, he imitated the humming of flies and mooning of little cows. And the cow started whipping her tail from side to side and walked closer to the peasant as if to hear the music better. It is not like that the music of Mahesh and Keshav was not interesting, but music of peasant was up to the mark because cow was familiar with mooning of small cows and of sound of bees. So statistical methods and data analysis are context specific. With this, I close my presentation. Thank you so much.
Thank you very much, sir. It was so enriching. You know, as a teacher of sociology, I also teach these scales to my students, but probably I have better understanding of these scales now. And you know, the way you expressed it with practical stories and the way you ended up with the summation that statistical methods and data analysis are content specific, they all have their advantages and disadvantages, was excellent. I'm thankful to you, and I'm thankful to Amit sir that who persuaded me that we have to get a Professor Anurag Saxena ji for one talk, and it is very beneficial for the students. Now, before I move for some questions, I'll request Dr. A.M. Saklani ji, Deputy Director, IGNOU Regional Center, Noida, to please give his observations and comments. Saklani, sir.
I'm thankful to Professor Anurag Saxena for this nicely structured and illustrated presentation. Sir, you have touched upon important elements of quantitative data analysis by giving very rich examples and visuals so as to make the concepts clearer. I'm sure our participants have benefited a lot from this session. I thank you again, sir.
Thank you so much.
Yeah. Sir, I take 2-3 questions which have come up from the participants.
Surely.
Yeah. In cross tabulation, age and income are dependent variable or independent variable?
No, they are two independent variables. What we are trying to see is whether there is dependence of age on income or income on age. So this is, for this we have set our hypothesis that they are having no dependence on each other, and we apply chi-square test. Based on the value of chi-square, we ascertain whether they are dependent or independent.
Thank you, sir. Archana Saurabh wants to ask, chi-square test deals with which scale of measurement?
Nominal and ordinal variables. Because I said if we go for interval and we go for chi-square, you'll get a table of magnitude of suppose 50 by 3. So you cannot basically interpret that kind of table.
Thank you, sir. Thank you very much. Dr. Jogendra Pal Kukreja is asking, what is the physical significance of kurtosis?
Kurtosis.
Yeah.
Kurtosis is basically the peakedness of the curve. So you've got a flat umbrella. If you close that umbrella, it becomes pointed. So that pointedness or peakedness is called kurtosis.
Thank you, sir. And number of participants have asked for the presentation also, sir, that they are saying that this presentation is going to be very beneficial for them. So I'll request you if you could please give your presentation also in to me in email, and I'll send it to all participants, sir.
Okay, I'll do that.
Thank you, sir. Thank you very much. Now I request Dr. Moni to please deliver the vote of thanks.
Thank you, sir. Thank you, sir. Your lecture was very innovative, thought-provoking, inspiring. The analysis will be of great help. He explained measurement scale, the classification of measurement scale like nominal, ordinal, interval ratios. They were very interesting. Like he also explained how the measurement of central tendency is useful, like median and modes are useful in nominal scales, bivariant analysis, cross tabulation, degree of freedom. Thank you, sir, for your such an innovative lecture. I thank you, sir, on behalf of NAS College Merit Management Committee, Principal, staff member, and participant, Indira Gandhi National Open University Regional Center, Noida, and Dr. Sanjeev Mahajan, Head Department of Sociology and convener of this workshop. Thank you, sir, for sparing your valuable time and for your presentation. Thank you very much, sir. Thanks a lot, sir.
Thanks a lot.
Again, sir, on behalf of IGNOU Regional Center, Noida, and my college, I am really thankful on behalf of all the participants for such an inspiring, such a beautiful illustration of statistical issues or tools of analysis, which probably are a fair for social science students, sir.
Thanks, Sanjeev, and thanks, Dr. Saklani. Thank you for your kind words.
Thank you, sir. Thank you. Hope to get same kind of a patronage in future also, sir. We'll request that if you can spare some time for our students also in future, sir.
Definitely, definitely. It will be my pleasure.
Thank you, sir. Thank you very much, sir.